Hello, pre-calc. So here we go. Basically, this is sort of a little overview of quadratics from Algebra 2. So you could also just go off the filled out notes, but what we're going to start off with is multiplying binomials. And so here we have 3 of them. So what I like to do is I'm going to start off with a really thick, so let me make that a little bit thinner, but I don't remember how. Okay, so I'm going to FOIL this. So remember, that's going to be x squared, and then I do the OI all at once. So 5x, negative 5 plus 2 is a negative 3x. 2 minus 5 is negative 10. And then we have to multiply that still by x minus 6. Now, if you do it all in one line, what you're going to find is it's going to be very long, and it's easy to kind of get lost. So what I'm going to do is I'm going to first distribute the x to all my terms. So that gives me x cubed minus 3x squared minus 10x. And then when I go to do the second row, I'm going to do it underneath and then have the like terms add together. So then we have negative 6x squared. So I'm going to put this underneath, and then positive 18x, and then we have a positive 60. So we can now just add down all our like terms. So our final answer is x cubed minus 9x squared and plus 8x plus 60. Okay, so hopefully that was all right. So you're just multiplying. I just wanted to show that when you do the second term, it's easier if you do it underneath and gather all your like terms. Now what we're going to look at is factoring. So hopefully you remember the first thing you have to do is set your equation equal to 0. So I'm going to add 15 to both sides. So what we're really trying to factor is x squared plus 6x minus 40 equals 0. And so I usually do, and I don't care what method you use. You can use the methods that I show you. If you know a different method, by all means, feel free to use what you're comfortable with. So what goes on top is a times c, so 1 times a negative 40. The middle term, 6, goes on the bottom, and you ask yourself, what times what multiplies to a negative 40 but adds to 6? And that would be a positive 10 minus 4. So we have here x plus 10, x minus 4 equals 0. So x equals negative 10 or 4. Okay? Now, those are pretty friendly. What happens when a is not 1? That's always the harder, right? So what we're going to do, I'm trying to I don't remember, I haven't done a video in so long, I don't remember how to make my pen not so thick. I don't know how to do that. All right, sorry. So solve the equation by factoring. So now notice we have 15x squared minus 32x minus 7 equals 0. I'm going to show you this the long way, which always works, and a shortcut way, because I don't have the patience for the long way. But either way, I always start off the same with the little diamond. And so with the diamond, again, on top goes a times c. So 15 times a negative 7 is a negative 105, and negative 32 goes on the bottom. And so, I don't know, 105, we're looking at factors of that. So sometimes what I'll have to do is a little factor tree. So 5 times 21, well, that doesn't add up to 32. So then let's look at factors of 21. If I rearrange those, notice that 5 and 7 give me 35, and then 3. So 35 and 3 will get me to 32 if I make this a negative 35 and a positive 3. So those are the two numbers I'm going to work with. And what we're going to do is we are going to create a factor by grouping. So I'm going to just rewrite this equation, and I'm going to replace the middle term with the negative 35x plus 3x. And that's the only thing I did, was replace the middle term with something I know that adds up to it. So now what we do is called factor by grouping. So I'm going to group those two, and I'm going to group those two. And when I look at the first two, what is common, they each have 5x. So that leaves me with 3x minus 7. And in the second term, I only have a 1. That's the only thing they have in common. So when your two parentheses are identical, it means you did it right. So this will become 3x minus 7. And then in the other parenthesis is everything sitting out in front. 5x plus 1. And then you can set it all equal to 0, so that we have 3x equals 7, x equals 7/3. Here you'll have 5x equals negative 1, so x equals negative 1/5. I think for right now, I'm just going to show you that method, and then when we get in class, I will show you a little shortcut for doing those as well. Okay, so then we're going to go on, and we are going to now review quadratic formula. Now, here is your quadratic formula in all its beauty, but I prefer to do the quadratic like this. Opposite of b over 2a plus or minus the radical of your discriminant, b squared minus 4ac. So I write it as two fractions for two reasons. Opposite of b over 2a represents your axis of symmetry, and then you have your plus one root and your minus the other root on the other side of that axis of symmetry. The other reason is when people simplify these, they often forget to simplify the second half of the numerator. They only simplify the opposite of b. So I find by splitting it into two, people tend not to make that mistake. So let's also talk about what does, I don't know what it was I just hit, what does the discriminant tell us? So b squared minus 4ac, that's the part under the radical. So if you remember, if you do b squared minus 4ac and get a negative number, that means you have two complex roots. If you get a 0, you have one real root. And if you get a positive number, you have two real roots. So it's kind of nice not only to do it first because it's the biggest, ugliest part of the quadratic formula, but it's also a nice way to figure out ahead of time if you even need to continue. Like if you're not going to need complex answers, then you probably can stop once you find that the discriminant tells you you're going to have complex roots. So remember, complex numbers involve I, the imaginary number, which is the square root of negative 1. If I square both sides, notice I get I squared is a negative 1. So when we're simplifying with a radical underneath, you just pull that negative out as an I. And complex numbers always come in conjugate pairs, always, 100% of the time. Okay, so let's solve this quadratic. So we have here a is 1, b is 14, c is 58, and the first thing I'm going to do is my discriminant. So I have here b squared, 14 squared is 196, minus 4 times 1 times 58. And when we work this out, you get a negative 36. All right, so I know I'm going to have a negative, or two complex roots. So I'll have a negative discriminant. So now we do it. X equals opposite of b, so negative 14 over 2 times 1, plus or minus the square root of negative 36. See how nice it is? If you've already figured out the discriminant, you just have to basically plug it in. You don't have to figure it out again. And so now what I have is negative 7 plus or minus 6i over 2. So our final answer is negative 7 plus or minus 3i. And that would be based on the quadratic formula. Okay? Now down here, they give us one of the roots, which is complex, and they want to know, first of all, what is the other complex root, and then they want us to verify. So the other root is going to be x equals 2 plus 3i. So your conjugate pairs have the same numbers, but the middle term, or the term before the sign before the imaginary part, are opposite. One's negative, one's positive. Now to verify that this really is a root, we're going to plug it in. So we have here 2 plus 3i squared minus 4 times 2 plus 3i plus 13 equals 0. So remember, you cannot distribute that. You have to FOIL this, 2 plus 3i. So that's going to give us, foiling that gives us 4 plus 12i, 6i plus 6i, plus 9i squared. And then we're going to distribute over here, minus 8 minus 12i plus 13. Now the I squared, remember, equals a negative 1. So what it does is it just, you get rid of it and then change the sign that came before. And now let's gather some of our like terms. So I have here 4 minus 9 minus 8 plus 13. So that's negative 5 minus 8, negative 13. That part equals 0, and we have 12i minus 12i. So that root did in fact work. Okay, so now we're going to review how to complete the square. And even though the instructions in the book are going to say find a vertex by completing the square, I'm going to show you a better way to do it. But there are times when you still want to know how to complete the square, especially when we get into conic sections. So you have your original equation, then you want to isolate x's on one side, constants on another. So I have x squared plus 6x plus blank, and I'm going to subtract 2 from both sides. So I'm going to be adding something to both. What do I add? I'm going to be adding half of the middle term squared. So 3 squared is 9. And what that does is it creates a perfect square. A perfect square, remember, is like a plus b squared, something times itself. So you can either try and factor that, which is really easy, or know that when you do factor it, it'll always be x. The sign will always be whatever that sign was in front of your middle term, and then whatever's in the parentheses. Half of 6 is 3. So x plus 3 squared, because 3 times 3 is 9, 3 plus 3 is 6. That all equals 7. Now that might be as far as you'd have to go for vertex form, but we are going to solve this puppy. So we take the square root of both sides. Do not forget your plus or minus. So squaring and square rooting undo each other. So this equals plus or minus rad 7. And last step is we isolate x. And that is completing the square. Now, in the book, they're going to ask you to complete the square to put something into vertex form. Remember, vertex form looks like this, x minus h squared plus k, where the vertex is hk. But the reality is, this a and this a are the same, so we already know a is going to be 3. To figure out what h is, we just find the vertex of our parabola. So remember, opposite of b over 2a finds the x coordinate, which goes with the h. So that's going to be negative 30 over 2 times 3. So that gives me a negative 5. So that's going to be my h. To find the k value, which goes with the y, we're going to plug it in. So 3 times a negative 5 squared plus 30 times negative 5 plus 32. So that's 25 times 3 is 75, minus 150 plus 32. So I've got a negative 75 plus 32, and that's going to give me a negative 43. So my vertex is at negative 5, negative 43. And so, again, the book is going to ask you to do completing the square. Well, you can't complete the square with a coefficient other than 1 in front of your squared term. So this is a much easier method. You don't have to factor out that lead coefficient. Just do your opposite of b over 2a and plug it in. All right. Again, I am a big stickler for labeling your axes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. I'm sorry, I didn't do that very. And then the that's my x-axis, and my y, I'm going to go by tens. Negative 10, 20, negative 30, negative 40, negative 50, 10, 20, 30, 40. All right. So we know that our vertex is going to be at negative 5, negative 43. So you always want to mark your critical points on the axis. So here's my vertex. I know that my y-intercept is going to be 32, because if I let x equal 0, y equals 32. So here's 32. That's where I'm going to cross. And then I'm going to use the symmetry of this graph. So if I'm 5 over up at 32, then at negative 10, I'm also at 32. So I have 3 points, and right now that's all I care about. Boom, boom, and boom, boom. There we go. All right, I hope that was a nice introduction. Do not forget to go back and do 4.1, which was assigned after the test, and then continue with 4.2. They're both from section 4.2.